Welcome to The Explainer. Today, we are diving into one of the biggest headaches for clean energy. But the solution, well, it's surprisingly simple. And it's a piece of tech that's somehow both ancient and totally futuristic.
Okay, so let's just jump right in with a question. It sounds almost like a kid's toy, right? But believe me, this exact, simple idea is actually the engine behind some of the most cutting-edge energy systems we have today. No joke.
But why? Why on earth is a simple spinning wheel so important? Well, to get that, you've got to understand this huge puzzle we're facing with renewable energy. And here it is, the heart of the problem. Renewables are, well, they're flaky. The sun doesn't care about our evening TV schedule, and the wind blows whenever it wants. So you get this massive gap between when we generate power and when we actually use it. And that gap, it can throw our entire grid into chaos. Which, of course, brings us to the solution. We need a way to bottle up all that amazing green energy to save it for a rainy day. Or, a calm, windless one. And what's really cool is how many different ways we've come up with to do this. Look at this. It's like a whole family of energy storage ideas. You've got the chemical route with batteries, you can trap heat, there are tons of options. And each one is good at something different. But today we're zeroing in on one particular member of that family. It's a real heavy hitter from the mechanical side of things, the flywheel. You can think of it as a mechanical battery. So what in the world is a flywheel energy storage system, or FSS for short? It's actually pretty straightforward. At its core, it's a device that takes electricity and uses it to spin a massive wheel, called a rotor, at just insane speeds. And all that energy? It's stored right there in the pure kinetic motion of that spin. Okay, so how does this thing actually work? Let's break it down. It's this beautiful, simple three-step dance. First up, charge. An electric motor grabs power, say from some solar panels, and just revs up that rotor, spinning it faster and faster. It's turning electricity into motion. Second, store. Now, the rotor just spins. It keeps on spinning in a super low-friction, vacuum-sealed chamber, basically just holding onto all that energy. And finally, discharge. When you need that power back, the spinning motion gets used to drive a generator. That turns the motion back into electricity, and boom, out it goes to the grid.
And this is where the modern magic really happens. To get those crazy speeds and be super efficient, these are not your grandfather's spinning tops. No way. We're talking about high-tech stuff, built from advanced carbon fiber composites so they don't fly apart. And get this, they often levitate on magnetic bearings to get rid of almost all friction. That's the secret sauce. That's how they hold on to energy for so long.
So you might be asking, why go through all this trouble? Well, the payoff is huge. First, these things have an incredibly long service life. We're talking decades, without really losing their punch, which is totally unlike batteries that fade over time. Plus, there's no pollution or chemical gunk to deal with. They're super efficient, they charge up incredibly fast, and honestly, they're a breeze to maintain. All right, let's really put this into perspective. Let's put flywheels head-to-head with the batteries we're all familiar with. Lifespan. A flywheel can last for decades. A battery? You're lucky to get several years. That is a massive difference. What about power? A flywheel can give you a huge burst of power, like right now, instantly. That's perfect for grid stabilization. Most batteries just can't do that. And the big one? Environmental impact. When a flywheel is done, it's just metal and composites. No toxic chemicals, no messy disposal problems like you have with batteries.
And look, this isn't just some cool idea stuck in a lab. These mechanical batteries are already out there, in the real world, doing some really important jobs. When it comes to the power grid, their number one job is to act as a giant shock absorber. Renewables can be choppy, right? One minute the sun is blazing, the next a cloud rolls in. A flywheel can instantly jump in and smooth out that dip, filling the gap to keep the electricity flowing to our homes and businesses perfectly steady.
And check this out. In public transport, they perform what is basically a magic trick. You know when a tram hits the brakes? All that energy is normally just wasted as heat. But with a flywheel, that braking energy gets captured and used to spin the flywheel up. Then, when the tram needs to accelerate again, it draws on that stored energy. It's genius. It saves a ton of power. Then you have high-tech factories. In places like that, a power flicker that lasts less than a second, just a blink, can destroy millions of dollars of product. It's a disaster. A flywheel acts as the ultimate bodyguard, providing instant, clean backup power to keep those critical robotic assembly lines running without so much as a hiccup. But here's a really interesting thought.
What if the flywheel's greatest strength isn't actually working alone, but as part of a team? This is really where the future of energy storage seems to be heading. And that brings us to the really exciting idea of hybrid energy storage systems, or HESS. The thinking here is super simple. Why pick just one? Why not combine the best features of different technologies to create a system that's way better than any one of them on its own?
And boy, is this a powerful partnership. Think of it like this. The flywheel is your sprinter. It's there for those quick, massive bursts of power you need to keep the grid's frequency rock solid from second to second. The battery, on the other hand, is your marathon runner. It handles the long-haul job of storing solar power from noon to use later that night. You put them together, and what you get is a grid that's way more resilient, flexible, and ready for anything.
So, we kind of end up right back where we started. The flywheel, at its core, is ancient technology. I mean, it's a spinning wheel. But when you reimagine it with 21st century materials and science, it transforms into this clean, super powerful, and incredibly durable tool for our energy grid. Now, it's probably not the only solution we'll need, but it does make you wonder, doesn't it? What other old ideas are just sitting there, waiting for a modern twist to help us build a clean energy future?